Hello, welcome to section 2, Mastering Advanced OOP in C++. In this section, we are going to learn about abstraction and encapsulation. We'll also learn about interfaces, and then there will be an exercise. In this video, we are going to learn about abstraction and encapsulation. In this video, we are going to cover data concepts of data abstraction and encapsulation in C++ using class. Now let's understand what is data abstraction. Now, a data abstraction can be defined as the separation between the interface and the implementation. So in many of the cases, we are using the header file, like the IOStream header file, and there are a number of classes within that header file, but we don't need to understand how they have been implemented. All we need to do is just to include that header file in our program, and we are good to go. So in this video, we are going to learn how to do that with our classes. And encapsulation can be defined as the method that binds the data and functions in such a way that they are bundled and they can be shared pretty easily. So let's understand these concepts of abstraction and encapsulation using an example. So what we have done here is we have created a new project and deleted the entire code. So that's what we have done so far. Now, in the previous examples, we used to define a class here in this file itself, and we used to write all the codes that goes with this. Now, in this video, we're going to separate them, and we are going to create an interface that can be reused without sharing the code with another user. The code can be shared in the form of a library, whereas the header file is required in the form of just text file, and those definitions will allow another user to reuse this code. So let's understand the concept. So far we have a CPP file here which is auto-generated. Now for interface the standard is we create a .h file. To do that, we just need to click on the file menu, click on new, and go to the file. So there is an option called C or C++ header. Just click on that, hit the go button, click next, and type the path. So let's assume that we are going to create an imaginary number. So we are going to name the class as IMAGNUM. So in this way, and we need to add this to debug and release. Just click all here and leave this as it is and just press finish. Okay, so it's asking me to give the full path. We can do is like this. So it will be created in the same folder, and now we have the header file here. Unfortunately, it just need to close it because the .h extension is missing, and I'm just going to hit the rename file and change it to header quickly. So now it's printed as a header file, and we just open this file. So now what we are going to do is we are going to define the interface of the class itself, which can be included in another program without looking at the implementation. So to do that, we need to type class name. So we have the basic format ready here, and now we need to define some of the member variables. So we have defined two member variables. Now it's time for us to create a couple of functions that will be used to operate on these member variables. So that is how the encapsulation will work. So we will create a set of functions that will allow an user to operate on this data, and those functions and these internal variables will be intertwined in such a way that they can be easily distributed, and at the same time they can be easily reused at any point of time. So the first function we should create is the constructor function, and the function name is the class name itself. So we just created a function with a signature that accepts two double variables. One is real, another one is the imaginary part. Now I'm just going to quickly create two more functions to access the data, and this is how the abstraction works. So the user who is using this class will not be able to access these variables directly. By access, I mean they cannot be read or written directly without the help of another member function. And this is which separates this member variable from the outside world. So the outside world cannot just simply come and change the data. So this is how the data abstraction will work. So I'm going to create two member function that sets the member variable from an external input, and it also another function that will return the value of the member variable to the external users. So to get the real value, we have one member function, and again, because we are just creating the interface here with the basic interface here, and next is to set. So we now have created two member functions, and we can now create an implementation file that basically which will contain the the implementation of this class. So in next time, what we need to do is just include this header file, and this will be done. Right now we have the access to the source code, but we can only distribute this header file, and this will create as an encapsulation as well as an abstraction for the member data. So let's understand how to create the implementation file. We can simply right click on this tab and click on the swap headers and source file, and as it doesn't exist, code blocks will allow us to create a new one, so we just create. And it will also ask us to add this file to this project, and we'll just click yes and select both of them if they are not selected, and hit the OK button. And in this case, the first thing we have to do is just like to use any other header file, we have to issue an include statement here, and within quotation, mind it, this has to be within quotation, and we just write the header file here. And the difference is, in many cases, in this kind of code, we write within less than and greater than equal to sign. Now this symbol indicates that this header file is a system header file, which compiler will find out itself. However, this is a custom made which we just created, so in this case it has to be quoted. So basically it instructs the compiler that this header file is in a non-standard location and you have to find it yourself. So we're done with this. So just now we can start implementing the code itself. So let's continue building up this code, and we just now need to implement all the functions, basically write the code behind all the member functions. So let's begin with the constructor function. So we'll first write the class name, then two colons, and then the function and the actual signature. So I'm just going to copy this signature from the header file itself just to speed up things. And we have two variables here. Real can be set to r underscore, and imaginary can be set to I underscore. So we just finished the constructor function implementation. Let's look at the next function, and we have the get value function. So we just need to copy this signature here. Start by writing the name of the class, function name. So what we need to do here is the return type should be in the beginning. Now, as the constructor function has no return type, so that's how we wrote it in this way. But for any function that has a return type, the return type should go in the beginning. So then the signature should be return type, class name, and the function name. So this code is also done. And let's look at the return type here. And I'm just going to copy the function signature from here. So the return type is void, class name is imaginum, colon, function name as well as the signature. So this is done. So now we have finished writing the entire class here. Now let's go to the main function where we can now include this our newly written class of an imaginary number, and we'll see how to use that. So the class definition and the implementation are in a different file. So all we need to do is just to include the definition, which is in a header file. And as we explained earlier, it should go within quotations. I have written the main function, the basic one, just to save time. Now we can start with defining an object. This class, say the real value is 5.1 and the imaginary value is 3.2. And we're going to write one statement here. So I just need to also ask compiler to include standard namespace. So the space is now here. So I'm going to print it to console. So we are just going to print the real value. And if we build this, it should build. And if I run it, so as expected, it's returning 5.1. Now with this example, we saw how a body of a class can be defined in a separate header file. Implementation of that class can be done in another source file, which is a .cpp file, and then this header file can be distributed to other users who can then include that header file and use the class without even worrying about the actual implementation. So the end user do not need to think how these real and imaginary numbers will be used within the class, because all the functions and the date member function and the data are bind together in the form of a single class, and there are clear interfaces. So the user only need to know the name of class object, create an object of that class, and then use the object of that class to set the member data as well as operate on the member data. So this header file has created an abstraction of basically a data abstraction for the user, as well as it has defined encapsulation of data and the member function and their relationship. So this is how broadly the data encapsulation and the abstraction works. In this video, we learned about advanced properties of class objects, mainly the data abstraction and encapsulation.